This Patreon update includes new artwork and code work. Using Ito Bubba's ultra dynamic sky blueprint as a foundation, I've created a new system in Vilous, Soldier of the North. I'm naming this creation the Dynamic Weather System. The Dynamic Weather System aims to create a realistic weather environment in Vilous, Soldier of the North by adding changing clouds, weather events, and temperature differences. What you're currently seeing on your screen are some simulated days that have been sped up to show changes better. In the video, 1 real-world minute is equal to 1 second. In-game, a full day-night cycle will last 84 minutes. Moving back to the dynamic weather system on the topic of clouds, we've added a better system to change cloud density. In the bottom of the screen, you'll see a logic flowchart. This is a basic representation of how the system works. In a technical sense, clouds work in 3 different stages: clear, normal, and overcast. It was observed early on, if the dynamic weather system reached an extreme in cloud coverage, such as clear or overcast, it had a tendency to get stuck like that and clouds had a hard time changing. Safeguards were put into place to prevent this, so clouds shouldn't get stuck like that. The clouds are considered in their normal stage when the cloud target density variable is between its minimum and maximum of 0.0 to 4.5. In this stage, 2 different variables that produce the clouds by interacting with the material will run through a linear interpolation progress, which will decide how the clouds look. The cloud density target variable will fluctuate plus minus 0.65 every minute and smoothly fade from the cloud density to the target density. Because an in-game day lasts an hour and 24 minutes, this means that clouds will update a total of 84 times throughout the day. This will happen regardless of what stage they're in. In the clear stage, there is a cloud density target of less than or equal to 0.0. The dynamic weather system will detect this, and on its next update will force an addition of a random float between 0.4 and 0.65 to the cloud density target, thus increasing cloud coverage. In the overcast stage, there is a cloud density target of greater than or equal to 4.5. The dynamic weather system will detect this on its next update and force the removal of a random float between 0.64 and 0.925 to the cloud density target, thus decreasing cloud coverage. I've also created and added 2 new particle effects to use with the dynamic weather system: rain and snow. As seen here, rain particle effects are GPU based, and each particle interacts with its environment to create a splashing and runoff effect. Particles and collisions are rendered by the GPU, so we can render more without having the player's hardware taking that much of a hit. We're still fine-tuning the visuals of this particle system. Snow, being shown now, is also rendered on the GPU. This allows us to render the large amount of particles that are needed to make the effect seem realistic. This particle is also in development, and we're playing around with making the snow stick to the ground, or anything else that it collides with. Rain and snow events, like cloud coverage, are random based on certain parameters that are pulled in about every 1 minute interval. In the code, temperature is measured in integers that match up to the Fahrenheit measuring system. Any event that occurs when the integer is equal to or below 32 will be snow, and anything that occurs above 32 will be rain. If a snow weather event is occurring, a safeguard is in place so that if another weather event update is pulled, it cannot change to rain, even if the temperature is above 32. This also works the opposite way for rain to snow. Weather events can occur if the cloud density target is 3.0 or greater. There is a node set that allows a 1 in 5 chance for a weather event to start if the conditions are right. If a weather event occurs for more than half a day, which would be 42 minutes, the storm will be forced to break up. Due to the random nature of the system, it is possible for a storm to start up a minute after one has been forced to stop. Rain and snow can also stop naturally. If the cloud density target variable is between 2.5 and 2.0, a node set will handle deciding if the weather event will stop. If the conditions are right, the weather event has a 1 in 5 chance to stop. Due to unrealistic conditions, weather events can be forced to stop naturally as well. If the cloud density target drops to 2.0 or below, then any weather event occurring will be forced to stop. Perhaps one of the most complex variables in the dynamic weather system is the variable for temperature. This variable pulls an update 4 times every day and controls the weather event that will occur if a chance is given to start one. The variable will also change based on parameters of cloud coverage and the presence of weather events. The default temperature of the northern regions of Vilous is 40 degrees Fahrenheit with a min-max temperature of 20 to 70. This is a logic flowchart that's pretty much explaining everything that would probably be too boring for me to sit here and talk you through. Since the players plan to only visit the Sailzane Desert on special occasions, weather there will be predetermined and the dynamic weather system will not be active in that region. If we do plan on adding the ability for the player to stay in the Sailzane Desert for extended periods of time, then we're just going to rewrite the variables that we have in our current dynamic weather system to better suit that of a desert.